Hi, welcome to the last live session of the Sponsored Topology NPTEL 2 course. My name is Shavik and this is the last live session for the semester for this course itself. Okay, so this will be a 2 hour session as usual. So before starting further, please let me know whether I am audible and is the screen visible to you. Please let me know.
Yes, you are audible and the screen is visible.
Okay, can you confirm one thing, Mustaq, whether is my voice clear?
Yes, your voice is clear.
Okay, thank you, Musa, for confirmation. So as I have already told you that this session is last session. So, if you have any question, please ask. So, I shall wait for a few moments.
No, you can continue.
Okay, thank you. So, how is it? How is your preparation for the final exam?
I'm just going well.
Okay, that's good. In case you have any doubt, don't hesitate to drop an email to me. Okay. Okay. So we can start by solving today's problem. So let me open the website. Okay. So before going to solve answer, there are some few questions which I want to you to solve. So let me write it down. Okay, let me write now. Kindly hold a moment, please. Okay, now I'm starting writing. So in case you have any doubt, please drop an please unmute yourself and tell me, because in message I may not able to see the message because while writing I don't get a notification. Okay, so let me start. So first question is the following. Okay, let f x to y be continuous function. Suppose f is bijective and x compact and y Hausdorff. Then show that f is a homeomorphism. Okay, so okay, so so if it is this problem known to you, then it's well and good. If not, then please take your time, think about it, and let me know. Okay, so this type of problems are very popular for exam from examination point of view. Okay, 1 minute. So try to solve it by yourself, take your time. So so let me solve it for you. So the solution goes as follows. Okay, water bottle. Okay, so solution goes as follows. Okay, point is that it is, I mean, see, f is given by continuous and bijective, and we need to show f is a homeomorphism. So what do we need to show? We actually need to show that f inverse continuous, right? F inverse is continuous, right? Which is enough to showing that f inverse of f is closed in X for any closed set f in Y, correct? Okay. And this is same as showing that f is a closed map. Okay, so that's the thing. So basically, in order to show if it's a homeomorphism, you actually need to show if it's a closed map. Okay, so try to show if it's a closed map. So for that, what you need to do, you need to so for that, okay, one. So for that, what you need to do, you need to choose choose a closed set, choose a closed set f. Sorry, choose a closed set. Choose a closed set f inside X, and you need to show f of v is a closed inside Y. Okay. So how to do? Think about it. It should not be a difficult problem now. So how to do it? Any idea? Okay. So basically, this can be done as follows. See, X compact so V closed implies V compact. Okay, there is no harm in that. There is no harm in this statement, right? Now, if it's continuous, so this implies f of V compact in Y. But why Hausdorff? So f of V is closed in Y. So finally, what we get? We choose the closed set, and finally we got that f of is closed in Y. So that is the argument. Okay. So there is nothing to explain much, I hope. Is it clear? So basically, The argument goes as follows. So the argument goes as follows. That if x2 is a continuous function, if it's bijective, x compact, y Hausdorff. Okay. So in order to show if it's homeomorphism, what we need to show? We need to show that f inverse continuous. Okay. F inverse continuous is same as showing that f inverse f is closed in x for any closed f in y. This same as showing that f is closed map. Okay. So now we are going to show f is a closed map. So what we choose a closed set V, and finally we have shown that f of finally we have shown what f of v is closed in y. So how we are getting this result is that v is closed and v compact. So f continuous, f of v is compact in y and y Hausdorff. So f of v is closed in y. Okay. So that is the argument. So that is the thing. So there is nothing to explain more, I hope. So is this clear? Mustaq, can you confirm? I mean, if in case you have any doubt, then you can ask and we do it. Okay. Okay. So okay. So that's the argument for this question. Okay. So now let's move on to solving assignment 11. Okay. So assignment 11, the first question. So the subjective. Okay. Suppose x equal to singleton AB, doubleton AB, equipped with Speronsky's topology, and y is T1 space. Then show that the space C of xy is homeo with y. X doubleton AB, Speronsky's topology. What we need to show y is a T1 space, so that C of xy is homeomorphic to y. Okay. So that is the thing. Take your time, think about it, let me know. Take your time, let me know. In case of, so since I didn't get a response, so let me give some hint for this. Okay, I mean, the first of all, see, x has only 2 points, x is 2 space. Okay, so basically any continuous map from x to y will fully be determined by image of these 2 points. Okay, t1, so those 2 points either can be equal or can be all of the y. Okay, so that's what the thing is. Okay, so what we need to prove is that, so that means to say what, any continuous map from x to y is constant. Okay, so what to do, so choose, so take f from x to y. That means what, that means f x to y is a continuous function. What we need to show, we want to show f is constant. Okay, how to do, so how to do, so if f of little a is equal to y, then as singleton y is closed, f inverse singleton y is equal to x. Okay, this implies that f is equal to cy, the constant. Therefore, so this tells that, so this tells that the corresponding of theta from where to where, sorry, theta from y to c of x y goes to theta y, each is bijection. Okay, and this also tells that for any open set u of y, say third bracket x comma u, that is equal to singleton a comma u, which is equal to singleton b comma u, and theta of u, that is equal to x comma u, and theta inverse of x comma u, that is equal to u. So this tells the theta is a homeomorphism. Okay, so that is the thing. So basically, no sooner, how to, so basically, no, 1 minute. Okay, so basically, no sooner we have uh, what, maybe, okay, so so no sooner we need to show that c of x y is equal to y, homeomorphic to y. So this tells that probably any continuous map from x to y is a constant function. Okay, so basically in this problem what we need to prove is that any map from x to y is a constant map. Okay, so what we have done is that we initially choose, so what I've done is that we choose f from x to y and we need to show the f is constant. That is what we need to show. Okay, now now so suppose f of a is equal to y, we choose a point a and suppose we are getting y. Now say singleton y is closed. Okay, so if inverse also closed, now f of inverse equal to y, so this implies what, f is equal to cy. Okay, the constant map. So this tells that y goes to theta is a bijection, and for any compact set u of y, x comma u is equal to singleton b comma u. So this tells that theta u is equal to x comma u, and theta inverse here, theta inverse of x comma u is equal to u. Okay, so this tells that theta is a homeomorphism. Is that clear? So yeah, so that is the argument. I hope this is clear. So okay, if it is okay, so take your time, let me know. In the meantime, please try to think about the next problem. So let me write it down. Just hold a moment, please. The next system goes as follows. Show that if X is any topo space and if Y is equal to singleton AB is the circumscript space, then y to the power x is connected. So how to do that? So okay, so take your time, think about it, let me know. Okay. Okay, so okay, so try to figure this out yourself. Let me check the next problem. And also, if the previous problem is clear to you, please let me know. If it is not clear to you, then also please let me know. Okay, take your time. let me okay. So solution goes as follows. Okay. So first of all, so let K be any compact subset of X. Then it is known that third bracket A comma singleton A as well as third bracket K comma Y third bracket means homotopy classes of maps. These two things contains the constant map C suffix A, the constant map what A. So this tells that y to the power x connected. Okay. So that is the argument. So there is nothing really more to explain, I guess. Okay. So that is the thing. Yeah. Okay. Okay. So let's go to the next problem. If you have any problem in this particular question number 2, then please ask, or else we move for the next question. Okay. So next question is as follows: show that if X is a discrete space and then for any topological space, sorry, for any topological space Y, the compact open topology and the product topo on Y to the power X is connected. If Y is discrete space, show that the compact open topology and the product topology on Y to is connected. Okay. Sorry, what does mean connect? Coincide. Sorry, it's my bad. So try to prove this. Take your time. Let me know. It's a very interesting problem, but I must mention. Okay, take your time. Let me know. Okay, so what I can tell is that directly, right? We accept. I mean, my hint is the following. Hint is the basically try to show that this third bracket k comma u, this thing is equal to intersection pi x inverse of u, where this intersection runs from finite intersection and x are the point coming to the compactness of the open covering of u by the points of k. Okay, so in that way you can think. Okay, so try to do it by yourself, take your time. So this is the hint, try to solve it by yourself. Okay, take a nice look at a few moments. So okay, 1 minute. Okay, so okay, so let me write it down. So it seems that this problem is not quite easy. I also was thinking about it, but it turns out that this, oh sorry, there is some issue with this problem, I guess. Okay, so let me sorry, let me figure this out. Okay, so the argument goes as follows. Okay, the argument goes as follows. First of all, the compact open topology is finer than the product topology on y to the power x. So to see the converse, first of all, so we are choosing what? Let k be compact in x. Okay. Now x discrete. So we can say that k is equal to x1, x2, xn. Okay. For some xi belongs to x. So there is no harm in that. Okay. So for any open set u in y, the set k comma y, this particular thing is exactly we can write as x1 x2 xn comma u, which is exactly equal to intersection pi xi inverse of u I is equal to 1 final intersection. So and this tells that pi of x denotes the projection map to the xi component. So this tells that k comma u, this belongs to the product upon on y to the power x. Okay, so that is the argument. I mean, there is nothing to explain. Okay, so that is the thing. Okay, so that is the argument. Okay, so there is nothing to explain more. So basically the argument goes as follows. So we have k comma u, basically we have k comma u intersection of pi of u. Okay, now it is compact open topology, this is finer, so the product topology on y to the power x. Now we want is the converse. For that, what we need to do, we need to choose a k to be compact in x, x to be discrete. Okay, and k be x1 x2 xn. Now so for any y u in y, third bracket k comma y is equal to intersection of pi xi inverse u. So this tells that sorry this tells that this tells that pi x denotes the projection map, and this tells k comma u subset of product topology on y to the power y. So that is the thing. Okay, is that so? I hope this argument is clear. In case you have any doubt, please 1 minute or so let me know. Okay, okay. So now the next question will be as follows. So let me write the next question here. The next question is that this question is quite big enough, I must mention. So okay, so next question is as follows. Okay, so hmm okay, so the next question is as follows. So let x, y, z be topological spaces and theta z2x be continuous. Then show that theta induces continuous map theta bar star cxy to czy defined by f going to f composite theta. This is both equipped with compact open topology. So what is the question? The question is that suppose there are three spaces x, y, z, okay, and these are continuous. Then what you need to show that theta induces a continuous map theta bar star defined by theta bar star of f equal to f composite theta. So this map is a continuous map. Okay, so take your time, think about it, let me know. It should not be a difficult problem. Okay. So take your time, let me know. Okay, so let me write it down. I mean, see, first of all, such a thing is quite obvious. Okay, so the argument goes as follows. Let K subset of Z be compact, okay, and W open in Y, okay. Now, since theta continuous and K compact, so theta K is compact obviously, sub of Y. Then f belongs to theta upper star inverse of K comma W, that is equal to theta upper star of F equal to theta composite F belongs to K comma W, okay, which is if and only if F composite theta K sub of W, which if and only if f of what if and only if f of theta K, okay, sub of W. This happens if and only if f belongs to theta K third bracket comma W. And what does this tells? This tells that inverse image of subbasic open sets are subbasic open sets under theta upper star, and hence theta upper star continuous. So that is the argument. So that is the argument. Okay, so there is nothing more to explain, I guess. Anyway, okay, went easy also. Sure. Anyway, okay. So basically, so basically, what I have done. So that is the argument. So basically what we have done is that, so k is subset of z, w is also y, and basically what we need to show, theta is compact. Okay, so what we've done, we are choosing f to be theta inverse comma kw. This happens if theta in upper star of f belongs to k comma w. It is same as saying that f of theta is subset of w, which is same as saying that f belongs to theta k comma w. The inverse image of the open set under theta, so it's continuous. Okay, so that is the argument. So there is nothing more to explain. Okay, now just hold a moment, let me open the other. Now let me open the MCQ. Okay, so the first question is as follows. No. Oh shit, what happened this? Just hold a moment, please. Okay, so the next object assembly. The first question is as follows. Sorry, there is an issue with the whiteboard, I guess. Let me reshare it. I'm extremely sorry for the inconvenience. So the first question is as follows. Question is, if x is Hausdorff, then y to the power x is Hausdorff for any topo space y. It is true or false? Okay, take your time, think about, let me know. I shall be back within a few moments. Okay, please take your time, think about, let me know. So Mustaq, are you able to figure out how to approach this problem, or do you have any idea? Okay. Okay, so it seems not. So anyway, let me explain. So first of all, it is false. Okay, why? Because take x to be 1 2 with a discrete topology. Okay, and y to be AB with Sierpinski's topology. Or any other non-Hausdorff space. So this tells that y to the power x is homeomorphic to y cross y, which cannot be Hausdorff obviously, which is not Hausdorff, which is quite obvious. So y, so x equal to 1 to discrete topology, y equal to singleton Sierpinski's topology, or any other non-Hausdorff, then y to the power x homeomorphic to y cross y, which cannot be Hausdorff. Okay. So that is the argument. Okay. So I think there is nothing. I mean, that's sufficient, I guess. Anyway, so now let me go to the next question. The next question goes as follows. So, for any two topospaces x and y, there exists an embedding of y in Cx cross y. True or false? Think about it, take your time, let me know. Okay. So basically, in this problem, I mean, the hint is, I mean, okay, so try to do it. I mean, there is nothing, there is no hint to give actually in this problem. Okay, take your time. Let me know. Hmm. Hmm. Oh, so okay, so let me write it down since it seems there is anyway. So first of all, it's a true statement only. Okay, how to write it down? See, the map theta to y to cxy defined by y goes to constant mapping y. So its image is y. Okay. Now k subset of y be compact. We are choosing to be compact. Okay. And any open set u in y, we have theta inverse third bracket k comma u, that is equal to y belongs to y, c of y belongs to angular bracket k comma u, that is exactly equal to u. Okay, so theta is continuous. Moreover, theta is open map from y to z. Now since u is open, so this implies if x belongs to x, theta u is equal to c u, u belongs to u, that is equal to angular bracket singleton x comma u intersection of x. Okay, so that is a thing here. And which is open in z anyway, so there is nothing more to explain, I guess. Okay, so now the next question. The next question is as follows. For any two spaces x and y, the subspace z c of y x to y with y belongs to y and c with constant function is y, c of y of x is equal to y. This circle also is closed in y to the power x. So basically for any two space x and y, the subspace z c of y x to y c of y to y, this is closed in y to the power x. So okay, so think about it, let me know. So the solution goes as follows. First of all, this is a false statement, okay? So how it is false? Take x to be doubleton y2 with discrete topology. And y to be doubleton AB, okay, with Speronsky's topology. Then the non-empty open sets y to the power x are y to the power x, comma, singleton y singleton a, which is equal to g comma ca, singleton to singleton a equal to f comma ca, and third bracket x comma singleton a, that is equal to singleton cm, and second bracket g ca f. This just hold the most for the 4 moments. Okay. So, and CGA which contains all of C suffix A. So, and this tells that y to the power x minus z cannot be open. Okay. So, that is the argument. Okay. So, so, so basically what we have done is the following. You have x equal to 1 minute. You have x equal to 1 2 and y is equal to a pen ab with Speronsky space. Okay. Now y to the power x equal to g comma cm and it is f comma c. Okay. Now y to the power x minus z, this cannot be open. So that is the argument. Okay. So there is nothing more to explain as per my understanding. Okay. So that is the thing. Now let me add to the next question. If x non-empty and C of xy connected, then y is necessarily connected. So, okay, think about it, let me know. Take your time. Okay. So in this case, hmm, first of all, it is true statement. Okay. Why? Because if we consider the projection P from C of xy to y given by f going to f of x, these are continuous, and of course and px are surjectives for all x belongs to x. So this implies what? Y connected. Okay, so that is the argument. So basically we need to find the construct functions. Okay, so there is nothing to explain more as per my understanding. Okay, so now we'll go to the next question. So if x finite, then the product topology and compact open topology on y to the power x are same. If x is finite, the product topology and the compact topology on y to the power x are same. So think about it, take your time, let me know. So now now okay, so first of all it is true statement. Okay, why? The first of all, the compact open topology this is finer than the product topology on y to the power x. Okay, and to see the converse, let k be compact in x. Now as x finite, k is equal to x1, x2, xn with xi belongs to x. Okay, so for any open set u in y, the set third bracket k comma u is equal to x1, x2, xn comma u. This is equal to intersection of pi xi inverse of u, which is equal to I equal to 1 to n. And this tells that pi of x denotes the projection map onto xth component. This tells k comma u belongs to product topology on y to the power x. Okay, so that is the argument. So I hope that is clear. So basically the argument is that compact open topology is final product y to the power x. Okay, so k is compact, so x is finite. Okay, so k of u is equal to intersection pi inverse, so this is the projection map. Okay, so this tells that k of u, this particular thing, belongs to the product. So that is the thing and that is the argument. Okay, okay. So now let's write the next question. The next question is that if y is infinite set with cofinite topology and x is any topo space, then C of xy connected. True or false? Think about it. Let me know. So the argument goes as follows here. So I mean, so okay, so I must give some hint first. Okay, so first of all, it is true. Okay, so now try to prove it. It is true, so try to prove it. Okay, think about it. Let me know. Okay, so first of all, basically if we take b of 1 to basis k1 comma e1 intersection kl comma ul. Okay, and if you take b2 is equal to k1 prime e1 prime intersection km prime um prime. Okay, for some compact sets, for some compact subsets ki kj prime of x and some open sets ui uj prime, okay, of y. Okay, so now the point is that what we need to do is that, so if we choose y naught belongs to y minus that union fi union fy prime, what we will get the c of y naught, this belongs to the all possible intersections, which is b1 intersection b2. Okay, so that is the argument. Anyway, so okay, so that's all for today. So okay, so this is the last session and today we shall stop here. So best wishes for your upcoming exam. Please try to so revise things as much as you can. In case you have a doubt, you can drop an email to me. I shall definitely get back to you very soon. Okay, thank you for your time and attention. So I hope we shall meet in next semester in points topology part 1 course. Those who are interested, if your friends are interested in the points topology part 1, then they can register the course. Possibly I'll be the tutor for this course itself. Okay, okay, so okay, thank you for your time. I will be leaving the session.